Hey guys. Okay, this is kind of the last limits video, so it's a big one. Although I'll try to be quick. So we got continuous functions. I've been talking about it in the last 3 videos, and indeterminate forms, I guess. So I shouldn't have put indeterminate limits in the title. So anyways, let's start with continuous because we talked about this a lot. So we talked about like how do you know if a limit is continuous or not? So what are the rules for continuous functions? So basically, if you're just looking at them, you know that it's continuous because you can see. If you were to draw the function, you don't have to pick up your pencil. That's obviously a continuous function. So all polynomial functions are continuous. Let's look at this rational function. This is not continuous. If I wanted to draw this graph, I would draw this part and pick up my pencil, and then I would draw this part. It's not continuous. Those piecewise functions from the last video, that's not continuous. So the function needs to have values for every x value. So the domain of continuous functions would be like xer. Okay. So we kind of already talked about this. So I'm just going to do a couple questions on continuous functions. So actually, how much do I want to talk about? Okay, let's just look at, I'm going to give you a graph and some equations. Okay, so let's say you had this graph of f of x. It's going to be a piecewise function. So right away, you know it's not going to be continuous. So let's say we have 0.5 x squared if x is less than 1. It equals -2 if x equals 1. And it equals negative x plus 3 if x is greater than 1. So if we just wanted to sketch this out, looks like x equals 1 is our big value here. So, rough sketch. So we know at at x equals 1, y is equal to -2. So I can put a dot right there. Then before that, on the left side, when x is less than 1, I got a parabola, 0.5 x squared. So if I just shove 1 in there, 0.5 times 1 squared, 1 squared is 1, 1 times 0.5 is 0.5. So I know that at 1, it's going to be 0.5, but it's not actually going to be because it doesn't exist at 1. I know my vertex is going to be at 0, 0 because it doesn't have a left or a right translation. It's going to look like this. So that's my parabola. Okay, and then I also have... I just want to get rid of this because it kind of looks like that's attached. I'm just trying to show that that's a value of 1. Okay, and then when x is greater than 1, I know that my equation is negative x plus 3. So I got a slope of -1 and a y-intercept of 3. Except that my y-intercept's not going to happen because my graph only exists for values greater than 1. So if my graph was at 1, -1 plus 3, I would be at 2. But I'm not going to be actually at 2 because I don't exist when x equals 1. And then my graph's going to go off in this direction. So with a slope of -1. Okay, cool. So that's my piecewise function. Okay, so if I wanted to evaluate the limits... Oh, actually, let's just say for the domain of this graph, I just want to mention, I said something earlier about continuous functions have a domain of xer. Well... That was silly because this domain is also xer because like there is a value for every x value, but it's not a continuous function. So that's interesting. Okay, let's evaluate some limits. So let's look at the limit as x approaches 1 from the left of our function. So from the left, we're in the parabola. And what y value are we approaching? Looks like we're approaching 0.5, I would say. And then our limit as we approach 1 from the right of f of x. So if we're on the right, looks like we're actually approaching... Yeah, 1 sec, honey.
I smell mint.
You smell mint? I'm chewing mint gum. Okay, so as we approach from the right, so let me finish this video, okay? It's my last one. You can watch. As we approach from the right, we're approaching a y value of 2. Okie dokie. So then, if we want to say, does the limit as x approaches 1 of f of x exist? I'm going to say no, because from the left and the right, it's different. So the limit does not exist. Interesting.
I'm going to go with you.
Okay, fine.
Oh, Mom, don't you want big?
No, I just want it like this. Okay, so try not to talk. Okay, let's also look at, like, what is the value of f of 1?
Are you looking at the iPad?
Yeah, I'm just writing a video. Okay, so f of 1, so if we sub a 1 in, or if we look at when x, oh wait, don't touch that. If we look at when x equals 1 on our graph, we actually get a y value of -2. Interesting. Honey, can you actually not touch that?
Sorry.
It's okay. Okay, so, what was I going to say? Oh yeah, so what happens, is this a continuous function? Well, to be continuous, the left and the right hand limits have to be the same. The limit has to exist, which it doesn't. And the limit actually has to be equal to the y value at that x value, which it's not. So therefore, the function is not continuous. It's actually a type of discontinuity called jump discontinuity. So there you go. Just one more comment on continuous functions. We talked about rational functions, and those are like types of functions that have asymptotes to them. They're also a type of discontinuity, and they're actually called, so this one's called jump discontinuity, blah, blah, and this one's actually called like an infinite.
Mom, why did you say blah, blah?
Blah, blah, blah.
Mom,
I don't like the word discontinuity. So this one's called infinite discontinuity. So they're kind of approaching.
Mama, can I try a chocolate cupcake?
After dinner. Okay, cool. So
I don't want to eat dinner. But then I have to go to bed.
true. Let's not fight over the iPad though, because you know my class is listening. Guys, I wanted to talk about one more thing. The indeterminate. Here, do you want to do the calculations on this? Okay.
Then you follow it.
Okay, I've got an assistant on the calculator. If we need any calculations done, Tori's on it.
Mom.
Oh my gosh, cosine. That's what she's got up. Okay, the limit as x approaches 1.
Mommy, you need to do the same letter.
Okay, I gotta first write this down. This is the actual question. X squared minus 3x plus 2. Okay, check out this function. What's going to happen when we sub a 1 in? Wait, I got to write. 1 minus 3 will be -2. -2 plus 2 is going to be 0. Oh.
Mom, why do you always keep coming up here?
So there's something, because I got to do work.
I don't want to eat dinner.
To hide.
I don't want to eat dinner.
Okay, no dinner then. You know what, guys? I'm going to come back to indeterminate form on the next video because somebody is going to be interrupting me, and that's probably annoying for you guys. I am so sorry. To be continued in the next video.